Stars. When most people hear that word, they tend to think about the ones in the night sky, but most people forget about the most important star of them all, the giant burning ball of gas without which life as we know it would not exist on Earth. So all the stars that we see in the night sky are all the same, giant nuclear reactors fusing hydrogen into helium and in the process producing huge amounts of heat and light energy, right? Well, not really. Just like everything else in the universe, stars are also diverse. There are various types of them, and each one of them possesses distinct characteristics. My name is Savata, and in this video, we're going to look at how stars come about, how they're able to power themselves throughout their entire lifespan, and what happens when they eventually die. If you're new to the channel or haven't yet subscribed, then please subscribe. Make sure you also click the notification bell to enable notifications so that you can get notified every time that a new video gets uploaded. In as much as stars are giant balls of burning gases, they actually start out from cold clouds made up of gas and dust that exists in between stars. Let us now look at star formation in detail. The clouds of dust and gas that lie between stars usually lie undisturbed for millions if not billions of years. Then spontaneously out of nowhere, maybe as a result of some kind of gravity disturbance, such as the passage of a nearby star or the shockwave from an exploding supernova, the disturbance will cause clumps to form inside the cloud. The clumps will then collapse inward, drawing gas inwards by gravity. The collapsing clump compresses and heats up. Then eventually this clump begins to rotate and flatten out into a disk. The disk continues to rotate faster, drawing more gas and dust inwards and continuing to heat up. After about 1 million years or so, a small, hot, dense core begins to form in the disk center, and this is called a protostar. A protostar is essentially what you have before a star forms, a collection of gas that has collapsed down from a giant molecular cloud. The protostar phase of stellar evolution lasts about 100,000 years. Over time, gravity and pressure increase, forcing the protostar to collapse down. All the energy released by the protostar at this stage is coming from the heating caused by gravitational energy, because at this point, nuclear fusion reactions haven't yet begun. When the temperature of the protostar reaches about 7 million degrees Kelvin, hydrogen begins to fuse to make helium and release energy. Material continues to fall into the young star for millions of years because the collapse due to gravity is greater than the outward pressure exerted by nuclear fusion. Therefore, the protostar's internal temperature continues to increase. If sufficient mass collapses into the protostar and the temperature gets hot enough for sustained fusion, then the protostar has a massive release of gas in the form of a jet called a bipolar flow. The bipolar flow clears away gas and dust from the young star. Some of this gas and dust may eventually collect to form planets. The young star is now stable in that the outward pressure by hydrogen fusion balances the inward pull of gravity. At this point, the star now enters the main sequence stage of its life, and we can officially say the star is born. Now that the star is stable, it will have the same parts as our sun. There will be the core, where nuclear fusion reactions occur, the radiative zone, where photons carry energy away from the core, and the convective zone, where convection currents carry energy toward the surface. Stars on the main sequence burn by fusing hydrogen into helium. Larger stars have higher core temperatures compared to smaller ones, and as a result, the larger stars tend to use up their hydrogen fuel much quickly than smaller ones. So larger stars usually burn for a shorter period, while smaller stars can burn for longer amounts of time. The amount of time spent on the main sequence depends on how quickly the hydrogen gets used up. For example, our sun still has enough hydrogen to power it for the next 10 billion years, give or take. Stars in the main sequence are in a state of hydrostatic equilibrium. Gravity pulls the star inward, but pressure from the fusion reactions pulls it outwards. Consequently, the two forces cancel each other out and the star maintains a spherical shape. Let's now look at two types of stars in order to illustrate the relationship between the rate at which a star uses its hydrogen and its overall lifespan. We're going to look at red dwarf stars and supergiant stars. We're going to start with the red dwarfs. Red dwarf stars are the most common kind of stars in the universe. These are main sequence stars, but they have much lower mass, so they are much cooler than stars like our Sun. Red dwarf stars also have another advantage. They are able to keep the hydrogen fuel mixing in their core at a much slower pace, and as such, they can conserve their fuel for longer periods than other stars. Due to the slow rate at which they use up their fuel, astronomers estimate that some red dwarf stars will burn for up to 10 trillion years. Next, we have supergiant stars. These are the largest stars in the universe. They are monsters with dozens of times the mass of the Sun. Unlike a relatively stable star like the Sun, supergiants are consuming hydrogen fuel at an enormous rate and will burn through all their fuel in their core within just a few million years. Supergiant stars live fast and die young. And when they die, they explode and completely disintegrate themselves in a supernova event. After a star has been born, has lived through its life, the next logical step is for it to die. This can happen anywhere from a few million years to hundreds of billions of years after it was born. The type of death that a star will undergo depends on what type of star it is. Let's first look at how stars with similar properties to the Sun die. When the core runs out of hydrogen fuel, it will contract under the weight of gravity. But at this point, some hydrogen fusion will still occur in the upper layers. As the core contracts, it heats up. This heats up the upper layers, causing them to expand. As the outer layers expand, the radius of the star will increase and it will become a red giant. At some point after this, the core will become hot enough to cause the helium to fuse into carbon. When the helium fuel also runs out, the core will expand and cool. The upper layers will expand and eject material that will collect around the dying star to form a planetary nebula. Finally, the core will cool into a white dwarf and then eventually into a black dwarf. This entire process will take a few billion years. We'll now look at stars more massive than the Sun. When the core runs out of hydrogen, these stars will also fuse helium into carbon. But the difference is that when the helium is gone, their mass is enough to fuse carbon into heavier elements such as oxygen, neon, silicon, magnesium, sulfur, and iron. Once the core has turned into iron, it can no longer burn. The star collapses under its own gravity and the iron core heats up. The core becomes so tightly packed that protons and electrons begin to merge to form neutrons. In less than a second, the iron core, which is about the size of Earth, shrinks to a neutron core with a radius of about 10 kilometers. The outer layers of the star fall inward on the neutron core, thereby crushing it further. The core then heats up to billions of degrees and explodes in a supernova, releasing large amounts of energy and material into space. The shockwave from the supernova can disturb other interstellar clouds and can even initiate star formation in these clouds. The remains of the core can form a neutron star or even a black hole, depending upon the mass of the original star. Inevitably, everything comes to an end. The Sun is about 4.6 billion years, and based on the observation of other stars, astronomers predict that it still has another 10 billion years in its lifespan. There are a lot of things that can happen between now and then, but in about 5 billion years, the Sun will turn into a red giant. Its core is going to shrink, but its outer layers will expand all the way out to the orbit of Mars. And since Earth is before Mars, Earth will be engulfed in the process. That's if the Earth will still be there at that point. The one thing most scientists agree on is that humans as a species will probably not be around at this time. In fact, humanity only has about 1 billion years left, unless we find a way of getting off this rock and colonizing another planet. This is because the sun has been increasing its brightness by about 10% every 1 billion years. A 10% increase may not sound like much, but in about 1 billion years, that increase will be enough to evaporate the world's oceans, and it will prevent water from forming on the surface. Unlike climate change, there's nothing we can do now that can slow down or even reverse the sun's eventual death. Our best option is to keep up our search of habitable worlds, so that by the time the sun is dying, we'd have already found another place that we can call home. If you're looking to hire a freelancer for services such as voiceover, web design, video editing and animation, content writing and translation, digital marketing, and many other services, then try Fiverr. You can find hundreds of professional and highly skilled freelancers who can get your work done in record time at reasonable prices. Some of the advantages of using Fiverr include: 1. There's guaranteed payment protection, because payment is only released to the freelancer once you're pleased and approve of the work that you get. 2. You already know the price upfront. You can find any service within minutes and know exactly what you're going to pay. No hourly rates, just a fixed price. 3. They have 24/7 customer service. Fiverr is there for you. Anything from answering questions to resolving issues at any time that you want to reach them. Check out the affiliate links in this video's description to get started and get unrivaled expertise trusted by the world's biggest brands. If you would like to advertise your products or services on our platform, then don't hesitate to contact us. You can send us an email or you can directly message us on our Facebook page, and we'll be able to get in touch with you and find out how best we can help your business grow. If you like what we do here and would like to sponsor us so that we can continue producing educative content like this one, then consider becoming a Patreon by going to patreon.com/Enceladom and become a patron so that you can keep us financially healthy. We've come to the end of the video, and thanks for watching. Please like, subscribe, and share this video with your friends so that they can also benefit one or two things.